Alrighty, this one is also a little unique. It has this absolute value. Absolute values are a little weird. Now, if you plug in 3, you get a 0 on the bottom, so we know we have to do some sort of method. We know we can't just cross those out because this absolute value is something weird. But what you can do with an absolute value, if you think about the property behind it, we're going to create two separate limits. One from the negative side and one from the positive side. So if it's from the negative side, here's what the function would be. All right, the top would stay the same, but the absolute value would be a negative x minus 3, because any number that's from the left side would create negatives on the bottom. So if you put anything left of 3, won't that be a 2? Create a negative. A 4, create a negative. Absolute value, make it positive. So if I put this negative out front, it basically takes all the values that would have been negative and makes them positive. Keeps them negative. So or does the opposite of it. It opposites it. So again, if this was a negative 2, the absolute value would have made it positive. But here, I make it positive by putting a negative. And now why can I put a negative? Again, because I'm going to the left side, negative side. And so I changed the function and made a little bitty adjustment. My other function is going to be the limit as x approaches 3 from the positive side. And that would, oops, I messed up there. That would be the following over x minus 3. We don't make any adjustments to here because anything above 3, won't that just be positive, and so the absolute value doesn't do anything. So again, basically we put the negative there to create a different way to say absolute value without absolute values. All right, so we're going to do each one individually and see if they come to the same point, and hopefully they will. So with that said, we can now cross this out with this, and we now have the limit as x approaches 3 from the negative side is x minus 3 cosine x. I'm going to put a negative 1 there. Instead of keeping it on the bottom, I just moved it up. All right. And then from there, let's plug in our numbers. Let's see what we get here. So if we plug in numbers here, what do we have here? Well, we have negative 1 times 3 minus 3 times cosine 3. Now you might go, what's cosine 3? I don't even know what that is, but look here. Before you can go there, don't freak out. Don't worry. This is a negative 1 times 0 times cosine 3. And what's 0 times all this? 0. So it actually works out kind of nicely because this really just is 0. Okay, so the left side, it goes to 0. Let's see what the other side does. So for the other one, don't these cross out again? Leave me the limit as x approaches 3 from the positive side. I now have x minus 3 cosine x. And when I plug in my numbers, won't this become a 3 minus 3 cosine 3? Should look familiar. When we do that, doesn't that become 0 times cosine 3? And when I do that, won't that be 0 times this is 0? So don't we have another 0? And if you remember the definition of a limit, isn't the definition of the limit saying the limit as x approaches 3 from the positive of f of x has to equal the limit of f of x as x approaches 3 from the negative side? Shouldn't these two sides be equal, and are they equal? So is there a limit? Yes, it's 0. It's where they're both approaching from both sides. That's a little tricky. And yes, these kind of problems are trickier when the absolute value. You have to make two different functions and come from both sides and see if they approach the same spot.